Alright guys, this is chapter 5, section 1, and this does with estimating finite sums using the rectangular approximation methods. Alright, so the first problem is distance traveled upstream. You are walking along the bank of a tidal river, watching the incoming tide carry a bottle upstream. You record the velocity of flow every 5 minutes for an hour, with the results shown in the table below. About how far upstream does the bottle travel during that hour? Find the left rectangular approximation method and the right rectangular approximation estimates using 12 subintervals of a length of 5. We're not going to show the table because we just pull out the values from the table and we're basically going to plug it into an equation. So they say to use subintervals of 5 minutes and we just converted those to seconds. So using the left rectangular approximation method, you're going to take that subinterval 300 seconds and multiply it by the values given in the table, which is 1, 1.2, 1.7 plus dot dot dot. We're not going to put all of them, but we used them in the calculator, and we're going to multiply those two together. And we get a distance of 5,220 meters that the bottle traveled during that period of time of 60 minutes. So then part B told us to use the right rectangular approximation method. Now using the same subintervals, you're going to multiply 300 times the values from the table, which are put here, which is fairly basic, and then you multiply those two together and you get the value 4,920 meters that the bottle traveled during that amount of time. Alright, next problem has to do with velocity. And it says that we had a table, but it said the table that below gives data for the velocity of a vintage sports car accelerating from 0 to 142 miles an hour in 36 seconds. And the table below, the table that we had gave us values that I'm just going to show you where we placed. And the first part of the problem says use rectangles to estimate how far the car traveled during 36 seconds it took to reach 142 miles an hour. So using what we're going to do is use the left rectangular approximation method and the right approximation method, and we're going to take the average of those two, because that gives us a better approximation of the amount the car traveled, because it basically takes the average of the two. So we plugged in the values for the left rectangular approximation method and got 0.898 miles that it traveled, and then the right rectangular approximation method gave us 1.04. That's because the right one is to the right of the graph and it overestimated, and the left one was to the left of it and it underestimated. So taking the average of that will give you, of course, a better estimate of the distance traveled. Now, for part B, it says roughly how many seconds did it take the car to reach the halfway point? How fast was the car going then? The halfway point equals 0.4845 miles. We just solved that by dividing the average time by 2. And then alright, okay. And then the next part just was the average. Okay, yeah, that was the total answer. Alright. So that divided by 2 at hour 0.006 and at 0.5665 at hour. Okay, so no, sorry. So these are the two values, alright, and these are the hours they were at. So we estimated that it took 0.006 hours, which equals 21.6 seconds, and that's how long it took the car to reach the halfway point. And the speed that we calculated, we just plugged that in, we got was 160 miles per hour. Alright, problem 3. Alright, this is the volume of a solid hemisphere. To estimate the volume of a solid hemisphere of a radius of 4, imagine its axis of symmetries to be the interval 0 to 4 on the x-axis. Partition the interval 0 to 4 into 8 subintervals of equal length and approximate the solid with cylinders based on the circular cross sections of this hemisphere perpendicular to the x-axis at subintervals left endpoints. Now, the equation they gave us was y equals the square root of 16 minus x squared. Part A tells us to find the sum, SA, because they told us, the sum is S of A because they told us to divide it into 4 subsections, of the volumes of the cylinders. And it asks us if we expect S of A to overestimate V or not. and they tell us to give a reason for our answers. So we're going to use the right rectangular approximation method, because that overestimates and it doesn't underestimate, and we could fix the error for that. So S of 8, once we solved for that with that equation, gave us 120.95132, and this is an underestimate because the rectangle is below the curve once you draw the graph. Part B says express the absolute value of V minus S of 8 as a percentage of V to the nearest percent. So they gave you an equation, you plug it in, the value's in, and you get approximately 0.1, and you multiply that by 100 and you get 10%.